Okay. Okay. So my name is Brian. My name is Brian. You can call me Brian, Mr. Brian, teacher, sir, up to you. Okay, I'm okay. Very chill. It's just us, right? So if you hear from your seniors, you might hear that pure science can be really hard and stuff like that. But I feel if you know what you're learning and if you know what is tested in the exam and what your examiner is expecting, then actually it's okay one now. Okay, I'm saying for physics especially. Okay, actually I do teach at maths and maths also, right? But right now I'm here to teach you physics. So in our classes, I will always highlight to you what you need to know for your exam. Because if you look at your reference book and all those things, sometimes we may be a bit overwhelmed with too much information, right? So this is, I think my notes are where you can always come back to for revision. And in the notes here, I think you guys have received the, oh yeah, does both of you have the notes already? And will you send the PDF files?
Received already, teacher.
Received already? Oh, Sarah, you don't have the notes, is it? Oh, okay. Right, that would be a problem. Okay, I will send now lah. Yeah, I'll send now to you. Oh, you just joined this morning. Okay, okay. Yeah. Um. Okay, you see whether you can download the file or not, right? Because actually, right, the way I teach is usually I will use the materials here, okay? And I'll go through with the materials here, explain everything here. Of course, sometimes I want to explain other things, I'll write aside, okay? But all the things that you will be writing mainly will be here. Whenever you want to do revision for your exam and everything, I believe it would be good to always come back to this notes lah, right? So as you can see in these notes, right, if you have opened up the, I think Chloe, probably you roughly saw, there are examples, right? There are questions and examples, and these are questions that they actually ask in SPM 1, right? So it's good to prepare you for what is really coming out in exam and all, right? Some things are not really exam questions, okay? Like in this case, in this page you see here, I might want you to complete together with me this table, right? There are a lot of blank spaces here, you know, right? And there are objective questions as oh, okay, or you give to me, you give me your phone number also can. I can WhatsApp to you. Okay, I can just WhatsApp to you. If not, I think it might be a bit hard now, right? You just give me your phone number. You can give me privately if you are afraid. Yeah, I can just WhatsApp to you. Okay, so it'll be great if next time, so today we'll go slower first, but next time, if can, right, I'll send it earlier lah, so you guys can go and print it, okay? And we will write on here, right, on the notes itself. So next time you can straight away refer to here, okay? And you see all these things in color. Don't worry lah. If you only have black and white printer or you don't want to waste ink, right? You just print everything in black and white. It's no problem one. Okay, you just print everything in black and white. I think you will still be able to see everything quite clearly one. Okay, all the blue or the green will become slightly grayish. Okay, if you cannot see, you just let me know now. Okay, next time if you cannot see, you just feedback to me. But you should be able to see, and it will just be slightly grayish. So don't worry too much about the color. The color is just to make it not so boring, right? Usually the color parts are part of the notes. Okay, can. So, okay, Chloe, you just give me 30 seconds because I'm going to send to Sarah the notes very quickly. I will need to save her number. Okay, so that everyone has got the notes and refer to it, know what is going on. You guys learn physics in English, right?
Yes, teacher.
Yes, yes, all in English, right? Okay, right. Sent to you already, Sarah. If you received it, you just let me know. Okay, so we'll go through the SPM exam format first. Okay, just so you know what you are getting yourself into and what you are going to expect in the real SPM, right? So in SPM, KSSM format and the old KBSM format and this new format is very similar, extremely similar. So you have 3 papers. Okay, paper 1 is all objective, where you have 40 questions. Last time was 50 questions, now it's just 40 questions. And the time is 1 hour, 15 minutes, right? So all the chapters will be tested. Nothing much. You got A, B, C, D, and then you, I think you're familiar with this. Okay, paper 2 is where it gets a bit serious, right? So most of the time, the focus is mainly on paper 2 and paper 1 because you look at the marks, a lot of marks here, and the total is 155, right? So how it works is you have the total. Oh, you're welcome, Sarah. You have a total of 155, and they will add up your total marks, divide by 155, and convert to 100%, right? So if you want to aim for a good score, you know where to work on, right? Paper 2, paper 1 is usually the place where you get a lot of marks. Okay, so paper 2 is when it gets a bit complicated because it's right. Section A, section B, section C. Okay, so section A, you got 8 structure question. Structure question is like what you see in your maybe PT3 sites, right? Maybe this is one possible structure question. Total got 1 mark, 3 mark, and 2 mark. This one is in total 6 marks. Okay, this could be one of it, right? And how they segregate the marks. This paper is 100 marks, correct? 60 marks will split into 8 separate questions, and you cannot choose one of these questions. You must answer all. Okay, so the first question will be 4 marks, confirm. Second question will always be 5 marks. Third question will be 6 marks. And then the 4th, 5th, 6th, 7th, 8th question, all 9 marks, 9 marks, 9 marks, 9 marks, 9 marks. Okay, so this is how it is. They already fixed this, and I don't think so they will. So it's always like that one, 4, 5, 6, and then 9, 9, 9, 9, 9. Okay, so that's where your 60 marks is, structure questions, shorter ones. Section B, right, you have 2 questions, and you only need to choose one. Okay, so for all your physics question, all your physics papers, everything is compulsory, you must do, except for this part. Section B, you can choose one. Okay, you can choose one. So one question will be 20 marks. Each question is 20, 20, and then you just have to answer one, right? And this is what we call as an essay question. Although it sounds a bit scary, because like, wow, essay question, in English you write essay, why science also need to write essay, right? But it's not that bad one, because the question, right, you just think of it as an extremely long structure question. There will still be some structure to it, meaning to say they will break it down, part A, part B, part C, part D, and you answer lor. And then there's one part which is 10 marks. Again, there's one part which is 10 marks. And this one is not too bad one. Okay. And that 10 marks, there's a part where we will do some decision making. Okay, they will do some decision making. This one later on in paper 2, you will see quite a bit. Okay, when it comes to that, I will let you know what it means by decision making. So for now, don't worry too much first. I just want to go through the format, and then in question, again 20 marks. Okay, there'll be same they split up the marks, and then there's one 10 marks, which is on modification. Okay, later on, I'll explain what is modification in chapter 2, right? And then paper 3, you have a experiment. You need to do your own experiment, record some data in the table. Usually they'll ask you to draw a graph and then maybe find out the gradient of the graph, things like that. Okay, it's not too bad because it's only very short, 15 marks. And speaking of the time, right, everything is very straightforward, except for paper 3, right? You have this 5 minutes plus 40 minutes. So 5 minutes is for you to check all your apparatus. Before you start, they'll give you some time to check. They'll give you a checklist also, see whether or not you have all your apparatus and all your materials that you need. Okay, so you just tick, make sure you have everything. And then the 40 minutes is when you do the experiment, record the data, answer a few very short questions, and then you're done. Okay, it's not too difficult. So far from my students, I heard that out of the 3 sciences, just the recent SPM, physics is the easiest one. Bio is usually the most difficult one, because bio, you need to deal with like maybe plants. I heard this year they deal with like tomato juice or things like that, right? So sometimes a bit hard to control. Physics is the one that you can control better a bit. Too worried about paper 3 for now. Okay, we will focus on the contents of in paper 1 and paper 2 first. Okay, and then for your syllabus, there are in total 13 chapters. Form 1 got 6 chapters. Form 4, not Form 1, Form 4 got 6 chapters. Form 5 got 7 chapters. Right? Some chapters you maybe heard before. For example, heat, force, I think measurement also you roughly heard. Maybe you have heard of sound waves. Okay, sound wave. Light, definitely you heard before. You have definitely heard of reflection, refraction. But let's say you forget whatever you learned in PT3, never mind, don't worry too much. Okay, we will go through and start everything new again in Form 4, Form 5. So don't worry too much if you forget a bit of things already, right? And then there's force and motion. You see that there's force and motion 1, motion 2. Last time, it used to be a very big chapter, but now they split it up into 2 smaller chapters. Okay, so that's not so stressful when you learn this chapter, okay, because it's very, very long. And then there are other chapters like, I think electricity also, you probably heard before, maybe not electromagnetism, maybe you heard of magnetism before, and maybe a bit of nuclear physics, I think you probably heard before, like how to form atom bomb and all those. Okay? There'll be other things that are new, but like I said, don't worry so much about PT3. We'll leave PT3 behind, and we're going to learn everything. Not everything will be new, of course, but I don't want you to be stressed to think that a lot of things will be related, because really, if you focus well in Form 4 and Form 5, even if you think your science in Form 3, of course, I hope your science in Form 3 is good, but even though if your science in Form 3 is not very good, you will still in SPM 1. Okay, just know what you're learning in Form 4, Form 5. Right, so this chapter is probably the most chill chapter you will have in all of physics, because it's the shortest chapter, the shortest, and it doesn't have a lot of content, okay? The first thing that you'll be learning is on physical quantities, right? Physical quantities. But before that, whenever we talk about physics, it's basically the study of matter and energy, as well as the phenomena happening around us, all right? So in simple terms, basically physics, we study why things happen around us. Like for example, why does the earth revolve around the sun? Why does the moon revolve around the earth? Things like that, right? All these things don't happen because they happen. There's definitely some explanation, right? So physics is learning all these things, right? Bio, of course, you are learning about what is happening in your body, what is happening in living things and stuff like that. And chemistry is when you deal with usually chemicals and going into those chemicals and things like that, right? So 3 very different branches of science, okay? So physics is I feel, in my opinion, physics is the easiest because you can see with your own eyes. Like bio, the things are body. It's very hard to imagine sometimes. Okay, well, you know, sometimes it does happen in your body and you can feel it and stuff like that. But physics, you can actually see it, you can actually imagine it, you actually know that it exists. Okay, so in that sense, it might be easier to grasp what physics is. Okay, and measurement, the meaning of measurement is just the method to determine the value of a physical quantity, right? So, like I said, this chapter is very chill, so we just go through a few of the terms that I want you to know. What is measurement? So the method to determine the value of physical quantity. Let's say, if you want to measure your height, what will you do? You will probably go and take a measuring tape, right? So that's a kind of measurement. Okay, the act of using your measuring tape to measure your height. Or let's say if you want to measure your mass, okay, you want to measure how many kg you stand on a weighing scale, right? So that again is a way to measure your mass, okay? Measurement is just a method to determine a certain value of mass, certain value of height, things like that. So here comes another very important term. I think this is so far the most important one, physical quantity. Physical quantity, right, is basically a quantity that you can measure one, okay? A one. Like for example, just now we talked about mass, we talked about height. What else can you measure? You can measure temperature, right? Temperature. Okay. You can also measure things like what else? Time. Okay. What other examples do you guys have? Length. Okay, got a lot of examples. Volume. Okay, area, density. All these things you can measure one. Okay, what you can measure, we call it a physical quantity. Basically, anything that you can get a value from it. Okay, we call it a physical quantity. So in contrast, non-physical quantity would be what? Non-physical quantity is a quantity that cannot be measured. So one can measure, another one cannot measure. Very simple. So what you cannot measure? Feelings. Right? So one day you go home, suddenly you see your, okay, I don't want to say humans. Okay, suddenly you see your dog suddenly get angry and you don't know how angry is your dog, right? We cannot measure emotions. We cannot measure feelings, right? So this is something, an example of non-physical quantities, right? Okay, so, so now we learn two things. What is a physical quantity? A non-physical quantity, right? The next thing, just an intro, is units. Okay, the units that we are using, kg, meter, seconds, all this is called metric units, okay, which is most commonly used around the world. And the current metric system is called the International System of Units, which we call as the SI units. Okay, SI units, right? So these are things that you heard of in Form 1 already, so nothing new. The most important thing today. Physical quantities are categorized into base quantities and derived quantities. Okay, so just now we already learned that physical quantities are anything that you can measure, like temperature, mass, time, length, volume, density. These are a few examples that we have. Okay, of course, there are other examples also, right? But just so you know, right, the physical quantities got two types, quantity and derived quantity. Okay, this one very important. What is a base quantity? A base quantity is a physical quantity that cannot be derived from another physical quantity. Okay, cannot be derived. That means you cannot create all this physical quantity from other quantities. Okay, I give you one very good example. You look at this yellow color table here. We have length. Okay, all these seven, we have seven base quantities. Okay, all these seven, they are base quantities. So for example, length. Length is a base quantity because you cannot create length from other things. Okay. Versus like if you have area, am I right? Area is some length times breadth. You see, area you can create from other things. You can do other quantities, but length you cannot. Okay, length you cannot. Okay, length and breadth is the same thing. So you write length times length also is the same. Okay, so base quantities cannot be derived from other physical quantities. They are the most basic ones. Okay, so base quantity, you think of it as the most basic ones. Okay, so this 7, right? You must know this table, you must remember. I think this 7, they in your objective, you're definitely going to ask you list out base quantities. You're definitely going to see in objective questions, maybe in SPM, which one is base quantity, things like that, right? So very probable question, okay? So got 7, like I said. The first one is length, and the symbol is L, okay, normal L. And then there's mass. We cannot derive mass from anything else, and mass is M. Maybe I should also. So SI units for length is meter. Okay, SI units for length is meter, which we write as M. Like 50 meters, we write 50 M. Okay, mass we write as kg. Let's say the mass of 10 books would probably be 15 kg, for example. Okay, and then time, we also cannot derive time from anything else. Time is time. Okay, time cannot be created from other physical quantities. Symbol is small t. The unit is seconds, right? And then thermodynamic temperature. You think of the word, don't worry so much about the word thermodynamic, okay? Just temperature, just think of thermodynamic and temperature as the same thing. Why they add this word thermodynamic is because the temperature that we have been dealing with since Form 1, Form 2, Form 3, right, is actually thermodynamic temperature. Between thermodynamic temperature and there's another temperature is basically temperature, right? Actually, when we say 0 degrees Celsius, we call it a freezing point. Looking at the value itself, right, you will see that maybe 0 might be a very low value to you, okay, like versus 100 degrees Celsius. 100 degrees Celsius is definitely higher. But this 0 degrees Celsius, does it mean that it's nothing? No, it's actually not nothing. It's just a value that people fix, right? So maybe one day some other scientists decide to put 0 degrees Celsius as, I don't know, maybe my name is Brian, right? So let's say if I'm a scientist, let's say one day I say that the freezing point of water, maybe I'm going to put 50 B representing the name Brian, right? So all these things is people fix on. Okay, all these numbers are fixed by people. Why is it 100? We have to go back to the history. So this kind of temperature, when we are dealing with, is called thermodynamic temperature. Okay. So 0, when you say 0, it doesn't really mean nothing. It actually has a meaning to it. When we say 0 degrees Celsius, we know it's the freezing point of water, right? So don't worry so much. Even if you write temperature in exam only, it's fine. Okay, for now, just remember it as temperature. O is capital letter T. And the SI unit is not degrees Celsius, but Kelvin. Kelvin. Kelvin is capital letter K, not small letter K. And then electric current. Electric current, the symbol is I. Okay, not C. I. And the unit is ampere. We write as capital letter A. Okay, all these things, right, the units and all, you don't actually have to, because as you go along in your physics syllabus, you will get better and better, because there's one chapter on heat, okay, where you will deal a lot with temperature, and you will deal a lot with the unit Kelvin, okay, and you get the hang of it, and you get used to seeing this unit now. And then there'll be a chapter where you learn about electricity later in Form 5. And then you will deal a lot with ampere, right? All these things will slowly help you to remember those chapters. Last time when they teach, right, they only teach this 5, okay, in the old syllabus. But now they just put down 2 more, luminous intensity and also amount of substance. Okay, so you have to make sure you know all 7. Luminous intensity, the symbol is I, with a small little v. Okay, small little v here. This small little thing, in English, usually we call it a subscript. Okay, subscript. Yeah. So I with a small little v. Luminous intensity. Luminous intensity is basically, you can think of it as how bright something is. Okay, how bright something is. We do not go too much into what luminous intensity is. And for your syllabus, you just have to remember that luminous intensity is one of the base quantities will do you to explain and things like that. They just want you to know, as long as you are able to state the 7 base quantities, that is good enough for SPM. Okay, and the unit, SI unit is candela. Okay, candela. The symbol is CD. Okay, candela, CD. And then mole of substance. Okay, I don't know how much you have learned for your chemistry yet, but very, very soon, I've learned, you will hear about amount of substance. The symbol is N. And the unit, we will call it mole, M-O-L-E. Okay, I hope you grow to love chemistry. But if you so happen grow to hate chemistry, you probably hate mole a lot as well. Okay, because mole is in everything. Everything also got mole. Okay, if you learn chemistry, everything will have mole. So amount of substance is in terms of mole, right? So you learn more in detail in chemistry of mole. Okay, so like I said, just remember the 7. Okay, just remember the 7, know what they are, and that will do. Right. Okay, let's look at the first question. If you have printed the book out, the paper out, you can write on it. If not, you can write on a piece of paper first. Okay, all my questions got label one, so you can write, and then later on you can put down in your own notes after it's printed out also. Okay, so let's go through. A pendulum with mass of 60 grams and length of 20 cm is oscillated. Okay, a pendulum is something where you have a string usually, and there's a metal ball. Okay, usually there's a steel ball. You will let it swing like that. Okay, so this pendulum is 60 grams and has a length of 20 cm. Okay, it takes 1.8 seconds to make one complete oscillation. Okay, oscillation meaning a complete oscillation meaning it and come back. Okay, go and come back is counted as one complete oscillation. If you go only and then never come back, right, that is only half oscillation. Okay, one complete oscillation, always remember, must come back to the original position, then it's only considered as one complete oscillation. So swing and come back to original position. Huh? That means one complete oscillation. Okay, so in physics, right, once in a while, they like to ask you some definition one. Okay, what is meant by base quantity in part A? 1 mark. Right. Of course, some of you may say, hey, why I put down up here already and then down here I ask the same thing? Because these are real questions that they ask you to take this time to practice yourself in class, so that because if you write a few, okay, in class you probably need to write once only, but if you write a few times on certain definition and certain things, you probably remember it yourself better. And then in exam, you won't have to worry so much about purposely going to memorize the definition and things like that. Okay, usually I will, if there is a special formula related to the definition and stuff, I will teach you how I remember that you don't need to remember it word by word. In physics, we look a lot for the keywords. Okay, we look a lot for the keywords. So when I think about base quantities, let's say if you suddenly forget, right? Let's say if you suddenly forget, you just remember that Mr. Brian once said that base quantity cannot come from other things. Okay, cannot come from other quantities. Okay, then you put it into a better English sentence. It will just be base quantity is a physical quantity derived from other physical quantities, right? So just like that, that is your answer for part A, right? You just say base quantities. So usually if you have the papers printed out, we will do together in class, all these things. Let me move my pendulum away. Whee. Okay. From other physical quantities. Okay, base quantity is the most basic one. You cannot create base quantity from other quantities. Okay. Okay, now next they say list the base quantities involved in the experiment above and their SI units. Okay, so in this experiment, okay, in this experiment, a very simple two-sentence question. They give you a situation here, and they tell you that the pendulum with a mass of 60 gram and also a length of 20 cm is oscillated. Okay, and then there is 1.8 seconds. So all the things that has got numbers, that has got values, they're all physical quantities, right? So in this experiment, we know that mass is one of the, okay, we cannot create mass from other things. Length is another base quantity, and this 1.8 second is time. Okay, this 1.8 second is time. So they ask you to list the base quantities involved. You just have to mention, number one, you can write in point form. Okay, in exam, in SPM, you can write in point form. Number one, they ask you to list. So number one is mass. Okay, the SI unit is what? SI unit is kg or kilogram. Right? Number two is what? Number two is length. Length is another base quantity. The SI unit, don't get confused, although they use cm here, but the SI unit for length is in meters, right? Not in cm. Okay, in meters. And then there is another one, which is time. Time is also another base quantity. It's in seconds, the SI unit. Okay, you want to write in comma, comma, comma also can. I think we list out like that is clearer. Okay, we list out like that is clearer. Okay, and then in part C, list another two base quantities and their SI units. So we know that there are 7 in total. And what else? Got mass, length, time already. Then we still need, you can talk about temperature. If you didn't put the word thermodynamic, never mind, that one is fine. Temperature, the SI unit is Kelvin, okay, Kelvin, not degrees Celsius, remember? And then there is electric current. You can put down electric current. Okay, the SI unit is ampere, remember A. And then also got two more, right? Two more, the luminous intensity, okay, brightness of something. Okay, so they say list two, but let's just write all, because after all, we still need to remember all of it at the end of the day, all 7. Luminous intensity. The SI unit is CD, candela. And then got one more, which is amount of substance. Okay, that means how much of something. Okay, the proper way to measure how much of something, how much of certain chemicals or things like that is in mole. Okay. All right. So a very simple question that covers everything we have learned so far about base quantities, right? So for physical quantities, we know and split into 2, base quantities, derived quantities. So base quantities are the basic ones, the 7 that you must remember. Okay, can I? Let me know when you're done. Then I move on. If I'm too fast, am I too fast or anything? Okay, right? Or am I too slow? Just let me know. Or if you don't understand any, always just let me know. So far, so good? Okay. Thanks, Sarah. Chloe, are you still with me?
Okay, teacher.
Yeah, can I? Right. Let's continue. Okay, so we talked about base quantities that cannot be derived from other things. And then there is those that are derived from base quantities. For example, area that we talked about. Okay, but let's go through about the definition first, because they can actually ask you what is the meaning of derived quantity. Derived quantity is a physical quantity that is derived from base quantity 6, 7 to create other quantities. For example, area is created from multiplying the length and the breadth. Okay, the length and the breadth, or the length and the width, to form the area. And we form derived quantity by multiplication or division or both. Okay, so like for example, length times length give you area, right? We multiply. Sometimes you have things like where you do mass divided by volume. Okay, this one you learned before, density, mass divided by volume. Okay, or speed also, distance divided by time. Okay, there are others where you might need to do multiplication and also division at the same time. Okay, Ken. So for this table, right? For this table, you just go through together, and I think it'll be a good practice. The first one is on area. The formula is already given, length times length. We already know that. And in base unit, okay, it will be meter times meter. Okay, length times length is just meter times meter, which is meter squared. Okay, there's no special way of writing meter squared. Meter squared is just meter squared. So that's the most simplified one already. And then you also have volume, where you do length times length times length. And in unit, right, SI base unit, so you have meter times meter times meter. That will be meter cube. Okay, meter cube. So there are times when you might need to derive yourself in exam. Maybe you multiply certain things together or divide certain things. And let's say if you want to find out their units, you're not so sure. Okay, you actually can do using this method. Okay, for example, in exam, maybe you do volume. You know, density equals to mass divided by volume. let's say you want to find volume for some reason. Okay, it would be, if you rearrange it now, it would be mass divided by density. Density, the symbols are that. Okay, mass divided by density. And then let's say you're not sure the volume, the unit, is it cm cube, is it meter cube, or things like that. Okay, so in exam, you can actually go and use this method, like how I'm doing right now, to find out the units. Because in physics, for any calculations that you do, you must always leave your final answer in the correct unit. Okay, if you leave in the wrong unit, then your final answer is considered as wrong. Okay, in physics, we are very, very particular with the units. And if you don't write the units, also cannot. Okay, in maths, it's fine. If you don't write units, in maths also is fine. If you don't write the units, it's okay. But for physics, cannot. You must make sure that you must write the units. Okay, no units, no marks, no final marks. And then density. Density, we have mass, which is in kg, divided by volume. Since we already did volume, meter cube, I think we straight away write m cube lah, okay, meter cube. So usually we don't leave it like that, right? Most of the time we will write as kg meter to the power of -3. Okay, so this is something that you have learned in Form 3, your Form 3 maths. First chapter, okay, on indices, where if you move anything up or down, your algebra, you move anything up or down, the power, you need to put a negative one. Okay, if negative meaning it's supposed to be at the bottom one, but you go and move it up. Okay, remember that. So there's again no special way of writing it. So the simplified SI unit is also just kg per meter cube. Usually we read anything with negative or anything at the bottom as per meter cube. That's how we read it. So if you hear me say kg per meter cube, it means kg divided by meter cube. Okay. Per means divided. And then there is speed. Speed is distance divided by time. Distance we know is same as length, right? Distance is same as length. And the SI unit for distance would be in meters, would be in seconds. But you know, you usually don't write your units as 10 meter over second. Okay, maybe you do write it as like that, but then no problem. Okay, but usually most of the time we will write it as meter per second like this. Okay, anything you bring up, just put a negative power because this is supposed to be power 1. You move up, become power -1. Okay, displacement divided by time. You probably have not heard of the word displacement, but don't worry so much. There'll be a lot of terms here, or a lot of derived quantities that you will never hear before, but you are going to learn all this in the later chapters. Okay, you are going to learn all this in the later chapters. So don't worry so much first. I will explain to you roughly what they mean. And as we get to those chapters, then only we go deep into what are the proper meaning and other things with all those derived quantities. So for now, displacement is basically very similar to distance. Okay, displacement is very similar to distance. It's just that displacement has got a direction. Okay, so let's say like distance is like this. From here I travel to, from point A I travel to point B. Let's say here is 300 meter and here's 400 meter. Okay, the total distance 700 meters. That's the total distance. I don't care about the direction one. Okay, but displacement, we need to know what is the direction. Okay, and usually displacement, right, is the shortest distance from the starting point to the end point. Like this. Okay, displacement is something like this. So you can actually find out what is this purple color one by doing Pythagoras theorem. Okay, so the displacement is 500 meters. Displacement is the shortest distance with a very specific direction from A pointing towards B. Okay, but distance is that 300 plus 400. Okay, so displacement and speed are very, very similar. Okay, sorry, velocity and speed is very, very similar. Okay, velocity and speed very similar. That's why the symbol also similar one. Both also we use as v. So some students may ask, why speed we use v? Because actually it's due to velocity is v. Okay, that's why we use v. And then therefore the units will be meter over second again. Displacement is length, form of length. That is okay. And then acceleration is the velocity divided by time. Okay, the key thing is in the velocity part. Okay, don't worry because speed, velocity, acceleration, force, momentum, impulse, all this we will learn in chapter 2. Okay, we'll learn in chapter 2. Acceleration is velocity divided by the time. Okay, so you might want to write like this first. Okay, I'm not sure how good is your math. Okay, but this one, if I bring it up, it will also become s power negative 1. Okay, you can skip the light blue color one and straight away write like this, meter per second squared. Okay, meter per second squared. Right, because we learned that if you have two of the same base multiplied together, the powers are going to plus. Basically in maths from 3 last time, you learned that if you have these two together, you become s negative 2 because you have negative 1 plus another negative 1. Okay, so that's why meter per second squared. Okay, and then force is mass times acceleration. So your mass is in. Okay, acceleration is what? Meter per second squared. Just now we already did. So I put all together like this. Okay, I put all together, stick together like this. kg ms negative 2. So we already has kg meter per second squared. Kg meter per second squared. And there's a special SI unit for force, which you probably have heard before. I think in Form 2 or Form 3 you learn also that we call it as Newton. Okay, 1 Newton is the same as 1 kg per 1 kg meter per second squared. Okay, they are the same thing. You can write your units as this. You can write your units as Newton also can. Okay, so in this third column, we are writing in base unit. Base unit. That means like kg, meter, Kelvin, things like that. Okay, and then what else? Momentum. Momentum is mass times velocity. Mass times velocity. So mass is kg. Velocity, just now we learned already, is similar to speed. Therefore, we have meter per second. Okay, so kg meter per second. So the units we can write as kg meter per second, or do you know these two are very similar to each other? Right? These two are very similar to each other. Okay, so we can also write it as Newton second actually. Okay, Newton second. Why? Because Newton is kg meter per second squared. Am I right? If I go and times 1 second, right? This is Newton. This is Newton. Okay, kg meter. Am I right? If I go and put a second to the Newton there, it will become kg meter per second. Okay, because the s negative 2 will plus 1, it will become s negative 1. Right? So sometimes the questions can give you different units. Okay, or sometimes you might see your friend write different unit, you write different unit, but they could be the same thing actually. Okay, they could be the same thing. How you want to write it, right? Kg meter per second can. You want to write as ns also can. Newton second. Okay, Newton second also can. Okay, so this one I'll just leave it here, but let me move it up a bit now. Let me just box it up. Okay, and okay, I hope. The next one is on impulse. The formula for impulse is force times time. Okay, so since in the third column, this column, we want to write in the SI base unit. So force, just now we know, force is this one. Just now we already know is kg meter per second squared times time. It will become what? It will become k meter per second only. Okay. So momentum and impulse, they have the same formula one. Sorry, they have the same unit. Okay, they have the same unit. If you want to know, I can roughly tell you momentum is how difficult something, how difficult it is to stop something. Okay, let's say if you have a English that you have a lot of momentum right now to study. Okay, that means you keep on study, right? You have a lot of motivation to study, right? Or let's say if you see a lorry moving very fast and it's very hard for this heavy lorry to stop. That means the lorry actually have a very high momentum. Okay, so roughly that is the rough meaning of what momentum is. But like I said, don't worry too much for now because we'll go into deep detail in the next chapter of what momentum is. Pressure is force divided by surface area. So force is kg meter per second squared. Okay, I'm always referring back to this force. And then surface area is in meters squared. Okay, surface area is in meters squared. So it will end up becoming just, you see like this, you cancel 1 meter and then you, okay, maybe you know what? Because okay, you see we have kg, the meter, right? Well, because you have divide, right? Divide means you will minus. It will end up becoming kg meter -1 s -2 energy. So it's kg per meter per second squared. Okay? Kg per meter per second squared. Or we call it as Pascal. Okay, you can also call it as Pascal. Same thing. So 1 Pascal is 1 kg per meter per second squared. Very long, that's why we simplify to Pascal. Okay. And the hem, you just have to minus the power. Divide means minus the power, time plus together the power. Okay, multiply means times together. Frequency is 1 over the time period. Okay, 1 over the time period. Time is what? Time is in seconds, which you can write as s to the power of -1. Okay, s to the power of -1. So usually we don't write as s power -1 like that. Usually we call it hertz. Okay, hertz. Hz is read as hertz. Okay, hertz. And then work done or energy. I think you have learned before already some energy, like for example, kinetic energy. You have learned about probably potential energy. Kinetic energy is half mv squared. Potential energy is mgh and things like that, right? But don't worry so much. In physics, we don't really test you. So we don't have to memorize all. You don't have to memorize. The thing is that sometimes they will give you the formula and you need to know how to get the units. And the thing is that, right, by the time you reach from 5, okay, by the time you reach from 5, right, you will be very familiar with all the derived quantities already, because in all the different chapters, you are going to learn all of them in. So it will become to a point that you are going to do a lot of calculations in that chapter, and then you probably also know the unit already, because to know the formula is a must. If you don't know the formula, that means you don't know that chapter well enough, right? So when it reach those point, then you will naturally remember all those formulas. But do you need to memorize all these new formulas for now? Don't need. Okay, for now you don't need. You just know a few, know what are some of the theories to do. Okay, can? Right? Because if not, it'll be very unfair for you. Because all these things you are going to learn later on. Okay, you're going to learn later on. So this is just a rough introduction. Like I said, this chapter very chill one. This chapter very chill one. Know what is all the 7 base quantities. That one must know lah. Okay, derived quantities. You know everything else other than the 7 is derived quantities can already. Okay, and then they'll probably give you like some formula or what, because you know what is force ma. Okay, maybe you don't know, but maybe you know what is mass, maybe you know what is velocity, like speed, and then you probably can make up your own units from there. Okay, don't worry, because later on, when you start to look at the questions that they ask you, you will see what are the things that they usually ask. Right? So this one is just an introduction, something that is good to know. It's definitely useful in some points, okay, but don't need to memorize. Okay, don't worry about that. Okay, work done energy is force times displacement. Force is again kg meter per second, and then times displacement. Displacement is what? Displacement is the length just now, okay, similar to length. So the m and the m, right, will combine together, okay, to the power of 1, and then you have another m to the power of 1. So when combined together, the powers will plus become m squared. Okay, the simplified version for this one is joule, okay, joules, okay, Joules. So last time you also learned already work done energy a bit, okay, in your form 2, form 3. Power is work done time taken. Okay, work done divided by time taken. So when we simplify this, the s power negative 2 will divide with another second. It'll be -1 again. It is. Okay. Treat this as a practice only on your indices a bit, because all these things is important when it comes to calculation. When you time certain things, sometimes we might forget the unit for impulse, for example. If you do in SPM, you forget already. But you just look at the formula and then you see what you multiply together. From there also you can actually derive your own units, okay, usually. So this is just a practice for you to do that. And then charge is electric current. Electric current is what? Ampere times time. Okay, so it's just A times S, AS. And we usually simplify charge or electric charge as, okay, charge is Q, charge is Q, as Coulomb, C-O-U-L-O-M-B, Coulomb. And then we have voltage. Voltage is work done divided by charge. Work done is kg meter squared second -3 over charge, okay, which you can simplify as k squared. The a, when you bring out, become a power -1. The s, when you group together, okay, you will minus up, so it will become s to the power of -4. Okay, and for voltage, usually the unit we simplify it because it's very long. So usually we don't use this. We use volt. Okay, volt, V-O-L-T, volt, and the unit symbol is V. Okay, and then there is electrical resistance. So a few things here you will learn in Form 5 is voltage divided by current. Voltage is this of kg m squared a power -1 s power -4 divided by your current. okay, which can simplify to a negative 2 as negative 4. Okay, so this one, we usually don't write this. Nobody writes this. We call it ohm. Okay, if you have seen there's a watch brand that is this symbol is actually called omega. Okay, omega. If you learn AdMaths, right, you might have, okay, or later on, you might have, you might hear beta. All these are Greek letters. I think you have heard before actually in your Form 3 science when you learn about radiation. You probably might have heard of alpha, beta, gamma. Okay, omega is just one of the Greek letters. Okay, one of the Greek letters. All right, so very long this table, but something that is good to know. Don't need to purposely memorize. Just know how I did all this. Okay, just know how I did all this. Okay. And so far so good. Okay. I'll continue with example 1.2. Let me know if you are not done with any of this, or if you need me to you guys whatever I've written here. Okay, thank you, Sarah. If you need me to send to you whatever I've written here, you can let me know also. I can maybe screenshot and send to you. Okay, right. Example 1.2. Example 1.2. State the meaning of base quantity and derived quantity. Okay, again, another time they're asking us for definition. Okay, so how in physics they ask questions now. Meaning of base quantity. So I'll have one bullet point for base quantity. I'll have another bullet point for derived quantity. Okay, so just now we learned base quantity is the quantity that cannot be derived from other physical quantities. And then derived quantity is physical quantity that is derived. One is cannot derive, one is derived from other things. Okay, so base quantities are is a physical quantity. Okay, try to write yourself, try to think and remember and try to write yourself, because that way, when exam comes, right, you don't have to purposely go and memorize already. It's a physical quantity that cannot be derived from other physical quantities. Okay, then derived quantities is derived from base quantities. Okay, we create it from the base quantities together or dividing them, or sometimes we do both multiply and divide. Okay, so derived quantity is a physical quantity. Whatever I'm writing, you can do the same way in SPM. It's a physical quantity that is derived from quantities okay, derived from base quantities by multiplication division or both. Okay, you can multiply, you can divide, or multiply and divide together. Okay. Actually the definition is already on top just now. Okay, so if you want, you can highlight the definition now. You see that usually from the questions that you will be able to see what are the things that they usually like to ask, or what are the definitions that they like to ask. So you can highlight those off because those are what usually comes out in exam. Okay. And then part B, complete the table below for the derived quantity stated. Okay, so I don't think this is very likely to come out in exam. Okay, I don't think this is very likely to come out in exam, but it's a very good practice. Okay, it's a very good practice. So maybe they might ask you in your first Ujian, who knows, because in your first Ujian there isn't a lot of things to test. Okay, so maybe they might ask this. What is the symbol of area? Area usually we write as A like this. And what is the relationship of area with your base quantities? So when we say base quantity, the 7, okay, we're talking about length, we're talking about time, temperature, so on, so on, so on. Okay, so area is basically the length times length. Or in other words, you can simplify and write just length squared. Okay, it's just the length squared. And the SI unit, length is what? Meter ma. So you have a square, meaning would be m squared. Okay, so that is the. And then volume is capital letter V, right? And that is just going to be length times length times length. Usually we say length times the breadth times the height, okay? Or yeah, length times breadth times height. But because we want to write it as base quantity, I think it's better to just standardize everything as, because they're all length. Oh, this one will be length cube. Okay, so the SI unit is length is meter, length cube meaning meter cube. That is. And then density. Density, the symbol is something that looks like a P, but a very curvy P. Okay, a very curvy P. Something. Okay, that's how we write density. So later on, there is one chapter where you will deal with density a lot. Yeah. Okay, so density is mass. A chapter in Form 5, you deal with density a lot. Mass over volume. I think we can straight write like that. Okay, so this is the relationship. As long as I can see clearly that whatever, all the physical quantities you're writing here is in terms of the base quantities, then okay with it. Okay, mass over volume, right? Volume is length cube. Okay, maybe I write at the side that the formula for density is mass divided by volume. That's why I got m mass over length cube. Okay, so the unit will be kg. Length cube down there, we usually bring it up, but we put a negative. Okay, when you bring something up, put negative power. Okay, speed. When it comes to speed, right, you need to think of the cousin of speed or the brother of speed, which is velocity. Okay, why I want you to think of velocity? Because the symbol of speed is not S. The symbol of speed is small letter v. Okay, small letter v because of velocity. So velocity, the formula is distance divided by time for speed. Okay, we know distance divided by time. Distance we don't say distance in base quantity. In base quantity, it will be length, right? Therefore, we write length over time. Okay, length over time. You want to write distance over time first, can, no problem. And then you just change it, become like this. Distance over time equals to length over time. And length is in meters, so divided by time. If you move time go up, it will become second negative 1, that is. Okay, acceleration is your small letter a. Okay, acceleration is small letter a. Don't worry about this because acceleration you learn in chapter 2. Basically, the formula is the change velocity divided by the time. Okay, so change in velocity is what? Change velocity is length over time, just now we know. And then you divide by time again. Okay, when you divide by time 2 times, it will just become length divided by time. Length divided by time squared, or meter per second, right? Acceleration actually shouldn't be new to you because in Form 3 maths, I think you should have learned of the word speed before. Or Form 2 maths. You should have learned of speed before. You should have learned of acceleration before also. Okay. Acceleration meaning how fast you are going, right? If you are accelerating, that means you keep on getting faster. Okay. If you are slowing down, then we will call it deceleration, actually, the opposite of acceleration. Okay. Force is capital letter F. Okay. So most of it will follow the letters here one. But some capital letter, some small letter might be a bit confusing for now. When you do the chapters, it will be better a bit. Okay? When you do the chapters to learn force, learn on acceleration, you'll get better one. So force is mass times acceleration, which are definite. Acceleration is definitely not a base quantity. Okay, mass is lah. Okay, we know acceleration is length over time squared. Okay, so I'll just leave it like that. You want to write it as mass times length divided by time squared also can. Okay, you want to write like this also can, but basically it's the same now. So you can leave it as mass times length over time squared. As long as everything you write here got 3 mark, all in base quantity can already, right? So you see, this is a very good example of derived quantity being derived from base quantities through multiplication. Okay, through multiplication and division. So this question here, right, really just wants to tell you that we are actually multiplying our base quantities together for this case, dividing. Actually, down there also got length times length times length. So it's actually got divide and then got multiply also. Okay, so really they all come from your base quantities through multiplication or division. So force is going to be mass is kg. Okay, meters. Time, okay, over time squared is meter per second squared. Okay, so this is the SI unit. Oh wait, the SI unit for force is newtons, right? My bad. Maybe you write newtons way better. Okay, this is actually both accepted. Okay, both accepted. It's just Newton is the one, it's the special. Newton is better. Okay. Right, so these are some of the symbols. Formula-wise, don't need to memorize. When the time comes, you will remember everything, man, because all this you need to know in the later chapters. Okay, so for now, don't worry. Know how to derive a few of the know the meaning of base quantities, meaning of derived quantity. Okay. Okay. And you all let me know when you are done with this. Yeah. Okay. Sarah, okay, everything okay, can good. Oh, I realized something, right? I didn't really go through a lot of the symbols, as in this one is area, this one is volume, density, speed. I think most of it is okay, but some a bit special one like momentum is small letter P. Don't need to memorize, just roughly know, okay? Sorry, not Joe. J is Joe, but impulse is represented as J, pressure is P, frequency is F, work is W, power, charge is a bit special, okay? Charge, so momentum, impulse, charge is a bit special. Usually we write as Q, okay? And then there is resistance, electrical resistance R. Okay. We move on to the next example. Huh? Example 1.3. A car of mass 1,500 kg moves with a velocity of 25 meters per second from town P to town Q. It takes 2 hours to travel a distance of 180 km. After moving from town Q, it accelerates 20 meters per second squared to town R. Okay, so we have, maybe I write out the situation. So we got town P, go to town Q. Okay, this car has a mass of 1,000, so maybe we can highlight this 1,500 kg, and then velocity of this one from town P to town Q. Okay, and it takes 2 hours to travel a distance of 180 km. All this is for town P to town Q. So after reach town Q already, it will go to town R. And then go to town R, right? They never give a lot of information. They just say accelerate 20 meters per second squared. Okay, so in part A, they ask us to classify the above physical quantities into base quantities and derived quantities. And I've highlighted a few of the values. So the first one that we have is the mass, 1,500 kg. Okay, and we know for a fact that mass is a base quantity. So you write down here, mass is a base quantity. Next one, velocity. Okay, velocity is not a base quantity because velocity is similar to speed, remember? Distance divided by time. Okay, it comes from all your different base quantities or divided or both. So velocity will fall under a derived quantity. And then 2 hours. 2 hours is time. Okay, time we cannot derive from other things. is the most basic one, time. It's one of the 7. Okay. And then we have distance. Distance, no problem, because distance is length. So for the base quantity here, you can write length. Okay. Or you can put in bracket, we are referring to distance, base quantity. Then after moving from town Q, it acceleration, this one. Okay, acceleration is again another, because acceleration is the change in velocity divided by the time. Okay, so base quantity got 3, derived quantity got 2. We're done with part A already. Okay. And then in part B, the formula used to determine the engine thrust of a car above is equals thrust equals mass times acceleration. So this question very kind, because they know you haven't learned this chapter yet, learn other chapters yet, sorry. So they give you the formula for what thrust is. Okay, thrust is like a force like that. Okay, the force where if not your car cannot move, right? Okay, you need some force to let your car move. So it is mass times with the acceleration. That is how much thrust you need, okay, how much force you need. So they say that the formula is like that. You get the engine thrust, mass times the acceleration. So they say using the formula, determine the SI unit of thrust. Okay, so using the formula, determine the SI unit for thrust. We know thrust is mass times acceleration. Mass is what? Kg ma. Acceleration is what? Acceleration is the change in your velocity divided by time. So it's meter per square. Okay, meter per second squared. Or sometimes we call it meter per second. Same meaning, right? So you see or not, they will ask you the simple ones because all these you learned before, right? And then the difficult one, they ask you to go and multiply yourself from the simple ones to get. So this one is basically just kg meter per second squared. So this is the SI unit already. That's for part 1. Then part 2. Calculate the value of the engine thrust of a car when it moves from town Q to town R. Town Q to town R. So town Q to town R, we have, that means the one in green color, we only got one information. Okay, on town Q to town R. The acceleration is 20 meters per second. Okay, the acceleration is right per second. The mass is what? 1,500 kg. Okay, the acceleration is 20 meters per second squared. So the thrust is just 1,500 kg multiply 20 meters per second squared, which you will get as, okay, calculator time. Together you get 30,000 kg meter per second squared. Okay. If you want, so you can leave all your answers there. This is already the final answer. But if you want, you can actually change kg meter per second squared into newtons also. This one actually is newtons also. So they will accept both. Both also can. Okay, both also can. Or this one you want to write as 30 newtons also can. Okay, but the ones in the non-purple one also is fine. Huh? Okay, so you are done. Let me know, because I think we will stop here first. like I said, today is a very chill class first because it's just the first class. I don't want you to get too overwhelmed. The important things is know your 7 basic quantities, and then derived quantity is, okay, thank you, Sarah. Derived quantity is multiply or divide your base quantities together, okay? Remember that will do. Important thing for today's class, base quantity and derived quantities. In the next class, we'll go through a bit more, but that would be on other stuff already. Okay, this is a very short chapter. Yeah, sure, Sarah. Okay, right. So, Chloe, let me know when you're done, right? And if everything is fine, I will see you guys next week. Okay, all right, thanks, Chloe. Okay.